Before we get into any examples with this lesson, we're going to look at subtracting by using counters. So we're going to start with the first part here of 6 minus 4. And you'll notice that I have 6 positive chips already in here. So we have 6 positive chips. And now we have to take away 4 of them. Well, we have 4 positives to take away. So what I would do here is I would just remove 1, 2, 3, and 4. And that leaves us with 2 positives. So we could say that 6 minus 4 gives us 2. Now our next expression for part A was 6 plus a negative 4, and that could be shown down here. We started with 6 positives, and then we added 4 negatives to it. And what happens here is we have 4 zero pairs. So these 4 zero pairs will end up canceling each other out. And that leaves us with, again, a positive 2. So what we could say is 6 plus a negative 4 also equals a positive 2. For part B, it's a little different now. So we have 6 negatives to start with, and we're trying to take away 4 positives. What you'll notice up here, though, is that we don't have any positives to take away. So if we don't have positives to take away, we need to think about something that we could bring into the problem that isn't going to change this negative 6. So what I can't do, I can't just bring in 4 positives. Because if I bring in 4 positives, well, what happens is these cancel each other out. And that would leave us with a negative 2. That is not correct. What we have to bring in, we would have to bring in 4 zero pairs. So by bringing in these 4 zero pairs, this whole thing up here still equals negative 6. Because these 4 zero pairs are just 0. They're canceled out. But now what we're able to do, we're able to take away 4 positives. So I could remove these 4 positives, and then we are left with 6 and 4 negatives. That gives us a total of 10 negative chips. So what we know is that a negative 6 minus 4 equals a negative 10. And then for the next problem, we're not going to show this with chips because we already know we're good with addition right now. It's adding with the same signs. A negative 6 plus a negative 4 ends up giving us a negative 10 as well. For our next expression, we have 7 minus a negative 3. And again, we are in another situation here where we have 7 positives. There's 7 positives, but we don't have 3 negatives to take away. So what we have to do is we have to bring in, again, something that doesn't change this positive 7 or the value of these 7. And what would we add to that would be a 0. And in this case, we're going to bring in 3 zero pairs. By bringing in 3 zero pairs, the value of this whole amount of number chips does not change because these 3 are canceled out. And we're still left with 7 positives. But what this does do, this now allows us to take away 3 negatives. So if I remove these 3 negatives, that means that 7 minus a negative 3 is equal to a positive 10. And we also know that 7 plus 3 equals 10 as well. For our next one, we had 7 negatives, and we want to take away 3 negatives. So in this situation, because we have 7 negatives and we're trying to take away 3 negatives, we could do this. We have 3 negatives to remove. So I could just remove 1, 2, and 3. That's an X on that middle one there. And by doing that, that leaves us with 4 negatives. So a negative 7 minus a negative 3 equals a negative 4. And a negative 7 plus 3, because signs are different, when we're adding, we would actually subtract that, would also be a negative 4. So after figuring out all of our subtraction problems, what we should notice here is that in this case 6 minus 4 was 2. 6 plus a negative 4 also equaled 2. Then for our next one, we had negative 6 minus 4 gave us a negative 10. Negative 6 plus a negative 4 equals a negative 10. 7 minus negative 3 was 10. 7 plus 3 was 10. And then negative 7 minus negative 3 was negative 4. Negative 7 plus 3 was negative 4. There is a pattern in all of our sets here that we used. So in the first set, what we should notice is the first number stayed the same. Then our minus sign became plus, and then 4 became its opposite. We could check that with our next set as well. So for our next set, again, the first integers were both negative 6, minus again became plus, and the opposite of 4 was negative 4. Answers still the same. 7 and 7 were the same. Minus became plus. Opposite of negative 3 is positive 3. 10s are our answer. And then the last set, both are negative 7s. Minus became plus. Negative 3 became a positive 3. And the negative 4s stayed the same. What this actually shows us is our rule for subtracting integers. Instead of subtracting an integer, we can rewrite that as its additive inverse. Or what that means is we could rewrite it as adding the opposite. So what that means is if we had a minus b and we're subtracting a minus a positive b, that is the same as a plus a negative b, which is what we showed with our problems. We had 6 minus 4, and 6 minus 4 was the same as 6 plus a negative 4. Both of those gave us the same result of 2. The same as if you're subtracting a negative. If we were subtracting a negative, so let's say we had a minus a negative b, well, that is the same as a plus the opposite of negative b, which is b. An example we could use for that would be 7 minus a negative 3. That was the same as 7 plus 3. And both answers there would give us a 10. So that is the rule that we will focus on using for subtracting integers.